as systems are trying to store your data entirely in the form of binary format. So in binary number system also, it is going to approach, it is going to follow various kind of other systems. So something like, if you elaborate it, if you try to take binary codes, these are follows various kind of approaches. One is alphanumeric approach, or numeric approach also. Right? Alphanumeric approach means this is the binary code system where you can able to store the data either of alphabets, numbers, special symbols, or whatever it may be. Whereas coming to numerical approach, we can able to work with only numbers. We are trying to convert numbers into binary system. That's it. Whereas coming to here, alphabets also converted into number system. Right? So the simple examples for alphanumeric binary codes is ASCII, American Standard Code for Information Interchange, like capital A ASCII value is something and small a, right? So that is example. One is Unicode. Like this, we are going to have various kind of number system, binary code systems are there. Coming to alphanumeric system, whereas coming to numerical binary codes, basically it is going to store in one kind of approach that will comes under BCD approach, binary coded decimal approach. Binary coded decimal approach, also call it as 8421 approach. 8421 approach, right? Or some kind of 3321 approach, or we can take some other, like this. We are going to have various kind of approaches. These I can call it as weighted codes. Weighted codes. So let me tell why I am calling it as weighted codes. Okay. First I will tell the classification. In another kind of classification, they will be classified as non-weighted codes. In non-weighted codes, we are going to have one kind of codes are gray codes. Another kind of codes are Excess-3 code. Gray code and Excess-3 code, right? So here you can take 631 minus 1 is also one kind of representation, and something like 2421 is also one kind of representation. I mean, if you take the numerical binary codes in the system can able to store in various kind of different approaches. Among this, one kind of approach is 2421 system code, or 631 minus 1 approach, or BCD approach, or 3321 approach. Like this, it can be able to follow. Right? Simple thing. If you would like to write a letter in the system, how we are going to write the letter? You can able to write all in small letters. You can able to write all in capital letters. You can able to write all in capital letters. Combination of letters, like that. Based upon the requirement, you can able to follow various kind of approaches. Right? So first, I will go through what do you mean by 8421 approach. Right? If you take 8421 approach, this 8421 approach meaning that your decimal numbers are trying to store in which format? Binary system, right? In that binary system, one type of format is 8421, right? So what kind of numbers you can able to store? Decimal numbers, right? So try to think. This 8421 approach can able to have the pattern numbers from 0 to 9, right? How we are going to get the 0? By making all numbers as 0, by making 0001, 0010, 0011, 0100, 0101, 0110, 111, right? Fine. This is the basic thing what we are going to follow in 8421 approach, right? Guys, if somebody asking you to represent the number 12 in 8421 system, is it possible to store the 8421 in 12 in 8421 system? No, because its pattern is ranging from 0 to 9. You cannot able to represent other than this, right? But what is another way to represent this 12? So for 2 I can represent in the form of 0010, right? Meaning that each and every digit I can able to store in the form of 4 bits in 8421 approach, right? What about 10001? This represents 1, this represents 2, right? In 8421 approach, if I am going to have 4 decimal digits, how many bits are required? 16 bits are required, because each digit requires 4 bits, 4 bits, right? And this kind of pattern I can call it as sequential approach mode, sequential coding system అని కూడా పిలవచ్చు. We can call it as sequential coding system, because if you know one number, if you know one number, if you are going to add +1 to the existing number, you will get the next pattern, right? If you know 0, if I am going to add +1, I will get next number. If I add +1, I will get next number, and so on, right? Sequential means what? 1 followed by 1. And the next kind of approach is, let me come with the Excess-3 code first. Excess-3 code, right? This is one kind of pattern where you are going to store binary numbers. Okay, fine. So Excess-3 means what? Whatever the number that you are trying to store, instead of that number, you will simply add +3 to that number and you will store, right? If you would like to store 0 in the system, what you are going to store? We are going to simply add +3. +3 means what? 0011. 0 means 0011 in Excess-3 system, right? What about 1? 0100. Now understood, right? Right. 2 means 0110. 0111. Why you got 0111? 4 plus 3 is 7. Excess-3 means existing decimal system will be added with +3. So 5 means, right? So I can directly write 7 plus 3 is 10, 8 plus 3 is 11, and I think this one is 1100. Is it okay for everyone? Yes, right? So 9 plus 3, you are going to get 12. So what is the range of Excess-3 code system? 0 to 9 only. The range of Excess-3 code system also from 0 to 9, but the way they are storing is different. The way they are going to store is different, right? If somebody is asking you to, for example, 0011, 0111, 1101, and 1011, which of the following is not Excess-3 code? What is your answer? 1101, because in Excess-3 code system, what number is not possible? 13 is not possible. Up to 12 only it is possible. So this is the correct answer, right? And one more thing, can I call this as a sequential system? Yes or no? If you are going to add +1 to the existing system, you are going to generate next number. So sequential system I can call, and I can call it as one more important one, self-complementary system. Self-complementary system. What is the meaning of self-complementary system? Means if you take here 0 and 9, observe 0 and 9, they are complement to each other, ones complement to each other. 0011, if I am going to have ones complement, what you are going to get? 1100, right? That's the reason I can call it as complement to each other. But the condition is, if you are going to take a decimal number, there is one more condition you have to follow. If to say the number is self-complementary system, when you are going to consider decimal number, for this decimal number, you have to find out the 9th complement first. What is the 9th complement of 0? 9. 9. This number I can directly write 1's complement of 0. 1's complement of 0. Then I can call it as self complement. For example, I know 4 value in Excess-3 system. System. As I know, Excess-3 system is a self complementary system. First, what I will do? So you don't know the meaning of this one. Try to think. I will simply follow, as it is self complementary system. First, I will try to find out the 9th complement of 4. What is 9th complement of 4? 5. Right? As I find out the 9th complement of 4, it is 5. Its value is what? 1's complement of 4. What is 1's complement of 4? 1,000. I think this is the value only earlier exists. Right? This is what I can call it as self complementary system. Try to check. These two are complement. These two are complement. These two are complement, and this also complement to each other. So I can call it as self complementary system. Okay. So if you observe, Excess-3 will comes under non-weighted code. Why it is non-weighted code? Because if you take a particular value, you cannot able to assign an individual weight to it. Whereas coming to 8421 system, if you take this particular number 1, I can assign a value as 8. If you take this particular number 1, I can assign a value as 1. Whereas coming to this particular system, I cannot able to assign like that exactly. That's why it will comes under non-weighted code. And coming to one more system, 3321. 3321 is also a kind of self complementary system, is also a kind of sequential system. Okay, fine. How we are going to represent the 0 in 3321 notation? Can I write like all zeros? Yes or no? So 1 0001. See, now we understood that why it is weighted code, because each and every location having some weight. And what about number 2? 0010. What about number 3? Right? So if you take here number 3, you have multiple possibilities. One is 10000, another one is 0100, another possibility 0011. These are 3 possibilities. So among these 3, what you have to consider is the number which is having the least decimal value. What is the least decimal value? 0011. So you have to write that. Okay, fine. What about the number 4? So number 4 having the possibilities as 1001, 0101, which is having the least decimal value 0101, 0101, right? What about the number 5? Right? So you know the definition of self complementary system, right? Simply what I can do, 1010. Can I write? Because the complement of 4 is 5, and so 1's complement is 1010. So I can write like this. This one as 1100. If you want, you can just cross check. 1100. What is the value of this one? 1101. And what about this one? 1110. This one is 111. Right, guys? Here you may get confusion. Right? You are getting like not following the rules. Yes or no? Again, sir, you said like you have to take out the least decimal number system, right? You have to follow only for up to half of the numbers, and from that you have to find out its complements. Okay, fine. So this logic I have given for just for your remembrance only. Okay, fine. This is what I can call it as a 3321 system, right? So meaning that if you observe here, except 8421, all the remaining codes what I mentioned here will be comes under self complementary system. Self complementary system. It means that you can able to find out complement of one number which are below 4. Okay, and one more thing is, if you are able to add its weights, what is sum of 2421? 9. What is sum of 631 1 minus 1? 9. What is sum of 3321? 9. If a system is going to follow, if a system is going to say that self complementary system whose sum will be 9, but not vice versa. If I am saying that it is a self complementary system whose sum will definitely 9.